Hello, welcome to the latest demo for my custom programming language, Fae, F-A-E. Since my last demo, I have accomplished a handful of things, including adding methods to the language, object methods. And I figured what we could do is take the little demo program we wrote in the last demo video and continue to iterate it to be nicer. Start taking it from being just a messy interaction with C libraries, standard libc at this point, in this case, and start turning into something that looks like its own language in terms of APIs and such. In addition to methods, else, if, and break and continue were added to the language. I now have automatic pointer dereference for field access and method calls. I added isize to the language, which is assigned usize, size t in C, which is good because in Fae I'm experimenting with using assigned type for lengths and indices and sizes and stuff like that. And isize is good because it's better than i64 because it's the actual correct size guaranteed. And this means also over here in the C binding we wrote, I was able to switch this from i64 to isize to be a little bit more correct, because that's the actual signature. Added modulo and bit shift and bitwise operators. Bitwise operators, I mean like bitwise and an or and XOR. All of the binary operations, that is operations that have a left and a right, now have the assignment version. So there's now I guess it's not visible in this application, but like plus equals, minus equals, shift right equals, that sort of stuff. I fixed logical operators not short-circuiting, various other bugs. But I figured what we could do. I already came in here and I already changed the if ladder to be if else ladder. Now actually have modulo, so it's actually from 1 to 100. And what I figured I would tackle in this video is, in this little demo program, we have this unfortunate use of read, which is it's a bit of an unfortunate API. A little reminder, this is because the language does not yet currently have sized array types. So you got to just make a slice, which is right now, array literals just hand you a slice. The compiler just sticks it on the stack and then gives you a slice. So the type system doesn't have to think about the size yet. That's coming. So this is just a way to have a buffer. So what I was thinking is we should add some sort of file read abstraction, some sort of file object with some read on it, and some sort of ability to read into like a new line or something like that, because this is really jank right now. And we can, in order to do that, we need to create a list type, which is very cool because the whole point, that the reason this language is generic is for making lists. So what we can do is, I want to create a folder for collections in the standard library. This IO folder is empty. So is strings. Why do I have strings? Go away. We're going to create a new file called list.fae. And now I've already created a generic list type. First, generic list. This is a test case in the test library, the test suite. I can run the test suite. Look, there's all of them they ran. Each one of these is a little test program that can either attempt to build and fail with compile errors, in which it expects specific compile errors, or it can be expected to build and run and print specific things to standard out and standard error, and those are separate. Or it can be expected to build and then run with specific standard out, standard error, and then panic with a specific message. So test all this stuff. This is one of those test cases. This was me first writing some sort of generic list type, because I finally got generics in the language. This was before I had nice automatic dereference for pointers and for methods. So what we need to do is we need to build a list type so that we can use a list of U8 as the buffer type for the read operations. So you can pushes you towards reusing the allocation, but also lets it grow. So you can do something like read until new line. So that's what I want to do. And I figure we might as well start by just making the struct list. And I know it's going to need this stuff. I'm going to close that down. We'll talk about this stuff at the end of the demo because it's not really that important right now. We have a pointer to t, we have a length and a capacity. Those are going to become I size. Cool. And then we need to be able to construct this. So we need a static method on list. And the way methods work in the language is they are defined outside the struct. New. And it returns a list of t. And all methods, static or not, inherit the generic type parameters of the type. They can also be generic themselves. If the type and the method are inside a generic method, because you can define types and functions inside methods, inside functions, they also inherit the generic type parameters of the outer scope, which was a pain in the butt to implement, but it works and it's somewhat well tested. It's somewhat tested. So we need to return a list of, we're going to say, do I have a null? I do not have a null in here yet. I'm figuring I can put that in libc. Oh, I already have a null. Excellent. Cool. I have a null. So let's import that. Import libc null. Cool. So we can say putter. I'm going to call that pointer or items pointer. How about that? Items pointer. Now the language does not yet have private fields. Let me add that to the this dang editor. I don't even know. So these technically are accessible, but that's fine. I'm fine with that, especially since we need to be able to, like, it's useful to access these. These ideally would have some sort of getter, but so you just can't change it. The language is going to be public fields by default, but right now they're all public fields, so that's fine. We have a null of t. Length is 0 and capacity is 0. And we need to be able to push and get. Right now the language does not have operator overloading yet. I am intending to have some very basic operator overloading. Stuff like, oh, you can add two things together, but they have to be the same thing, because I don't like the type of confusion that can happen around, like, I'm overloading the addition operator, but I have to think, like, I have to build different overloads for different argument orders, and no, I don't like that. So this is how you define a method that has mutable access to self. And we'll say push. Item is a t. And inside non-static methods, you have access to self. And if it's like this, self is an immutable pointer to self. If it's like this, it's a mutable pointer. And we could have, like, self dereference and then dot items pointer, but we don't need to, because language now supports automatic pointer dereference for fields and method calls. So I am actually going to pull up this so that I can not have to think too hard about this while I'm demoing. I have written so many of these over the years, I should just be able to crank this out. Yeah, that makes sense. Okay. If self.length plus 1, because we're adding another one to the list, is greater than self capacity. Look at how much nicer that is. Look at how much nicer that is. I am actually going to come over here and we're going to double by 2. We have to grow the capacity. This is to handle... It's nice to have a list not initially allocate, because I could come up here and like allocate some sort of buffer here and have some sort of initial capacity, but it's nice to put that off until the first push, because that lets you freely create empty lists basically for free, because sometimes an API like needs an empty list, like a list, and you don't actually want to give it anything, so you create an empty list and it's allocation free, or you create a list that you then push to in a loop, but if the loop doesn't execute, you haven't paid for that allocation. So it's good to put this off. So that's what that's doing, because if capacity is 0, it's still going to be 0 here after the multiplication. And then this is going to be an I size. Size of t, yeah, times new capacity. Good. So that's the size of our buffer, and we need to reallocate that. And important to note here is that Fey does not have like loosey-goosey type conversions. It technically has the ability to, and there will be some places like, oh, you return a value out of a function that returns an optional thing. I'll wrap that in option for you, because that's just nice. But I have to cast this mutable pointer of t to a mutable pointer of u8 for the realloc call. And then new size, yeah, it needs to be a u size, because that's what malloc and realloc expect. And then we have to, because we're using realloc, it could either grow the buffer, the backing buffer, or it could create a new one if it can't grow it. And we need to be able to tell, I think I should just be able to compare. Oh no, I can't just compare the pointers, because the pointer types are technically different. If I were to come over here and say, just compare the pointers, and just to make sure everyone knows this is the cast syntax. If I do that, it's going to yell at me. Return. Oh yeah. Let's actually run it like that. Multiplication type mismatch. Sure. That's a bug in the compiler. Wait, what? Oh, I changed it on the compiler side, but not on the Prelude side. Whoops. Okay, yeah. So no realloc and free. Oh, is it actually going to let me do that? Does it actually allow this? Interesting. That might be a bug in the compiler. Ideally, like hypothetically, you could just compare pointers, but at some point, pointer comparison is going to deref to the equality operator of the underlying type. So this wouldn't work eventually anyway. So let's cast them to U size anyway. Actually, I wanna see if that actually gets to the point where it like works, because that would be interesting. Are those not in the, those are not in the libc bindings. Let's do that. I'll reorder those later. Not equals type mismatch. There we go. Left type is mutable pointer to U8. Right type is mutable pointer to T. That's what I thought. Okay, good. So we cast them both to U size. If they're different, we free the original item's pointer. That's good. That means that we actually ran the example program, which right now is just the original program. And then we need to assign the items point. We can come over here and say else self.items pointer equals pointer. Excellent. So now we know we have the capacity. This is ensure we have sufficient capacity for the new item. Cool. Now we know we have the capacity. We can get the pointer to the slot where we're going to put it. We can say slot equals items pointer. And now this is where we have a little bit of unfortunateness because Fey does not currently allow pointer arithmetic. I don't know if I want to allow it to have pointer arithmetic or have methods on pointers to like offset. I haven't decided yet. I'm about 50-50 on it, and I forget the reasons why. I had a good think about it. For now, though, we have to cast to U size. So items pointer plus size of T times length. Self.length. So what I'm doing here is I'm taking the address of the start and I'm offsetting it by where the next item is going to be. And this is going to be, yeah, that's going to be a U size. You actually need to be right. I believe this is why I don't want to have, might not want to have pointer arithmetic in the language, is because when you're trying to be a stickler for the type system and having things match correctly, when you start doing actual pointer arithmetic, you have to start casting between isize and usize a lot if you're using isize. But if there's a method that just accepts isize for offset by, and it can handle that internally, and like the computer doesn't care. It's still pointer arithmetic, but it's just for the nicer API. So you'll probably still be able to do this, but I'll have helper methods. I remember now why. So that, let's just make sure that assignment type mismatch, right. Over here, we need to cast it back to, because Realic gives us a pointer to the U8, because we don't have a void in Fey does not mean the same thing as void in C. So we say it gives you a pointer to bytes, but we need to cast it to a pointer to T, so we can assign there, and that's happy. So that means this all type checks. And what we need to do is we need to say slot as mutable pointer to T, dereference equal item. And so this is why I like having all of the binary, the unary operators. I don't know how to pronounce it. It's operators that only have the one thing. I like having them all on one side consistently, so you can chain them like that. So now we've done that, and we can say self.length plus equals 1. Cool. That should be it. Let me double check my logic. Yeah, cool. So the compiler's happy with that. I can close that down. I'll close that down as well. And now we need ability to get. What I'm thinking is method list non-mutable fun get index isize, which returns a t. And then I'm thinking method not mutable get ref, which returns a pointer to t, and then I'm not ref, and then a mutable method that get mute, which gives you a mutable pointer. So this is a little unfortunate. I don't love this, but eventually there will be square bracket overload for this. So but right now, operator overloading is not a thing in the language. So we have to do this. And this is as simple as, well, I say as simple as, basically this. Self items pointer plus size of times index as usize, and then we dereference that, and the compiler. I rusted myself. Null code paths for get ref and get mute. Excellent. So here we just return the actual pointer, and then here we return the pointer as mute. Expected return type of mute t got t. Oh yeah, no, don't dereference that. Excellent, cool. So now we have, ostensibly, we could also have a method mute list fun clear self dot capacity equals, no, we don't touch capacity, just len length equals 0, and we can also have a truncate to length size to length. Now, right now, Faye is taking the approach that objects are just data, and so the list is not responsible for calling any sort of destructor on your items. That might change. Right now, I've been leaning in that direction for pretty much the entire time I've been designing this language, which I've been designing this for a few years now. Just now getting into the groove of getting good progress, but those will work. Cool. So the compiler, I keep running cargo to run the compiler because the compiler's written in Rust. So running cargo runs the compiler. Okay, cool. So now we have this. And what I want to do now is actually use it. So what I'm thinking is I want to be able to not have buffer here, but instead say, let stood in, mute stood in equals file file descriptor from FD. Maybe we want to do that. Sure. And that is stood in description. That comes from libc. The libc bindings, that's just 0. And so we have the stood in there, and over here we also want to have mute buffer equals list of u8 new, and then here we can just say stood in dot read until new line buffer mute. Ta-da! And then if buffer dot length is greater than or equal to 0, because we don't, no, let's have an is empty method list is empty We'll return a bool. And we'll say return self.length is less than or equal to 0. That means it's empty. And we can have a method list fun has items, because I dislike inverting is empty. If I remember correctly, there was some sort of conversation in the Rust project about adding something like this, and it was shot down. Like, it's not that big of a deal, but I like to have that. So self.length is greater than 0. Cool. And so we can say if buffer.is empty, we can break. And then down here, and then we can do buffer dot push our null terminator, because we are still using A to L, so we still need that null terminator. And that's basically the API I want. So now I need to import Fey collections list. And it's going to complain about stood in. Let's just see all of the things it complains about, because I am proud of my compiler errors. So I want to see them. No file in the current scope. Cannot call method on typo because we override it with that. Let's get rid of that. No file. No red bytes. Yeah. Cannot index on type list. Cool. No field pointer on list. So that right there is going to be, this is why items pointer. This is why it's nice to have access to the pointer. Why do I keep doing that? Do that. No file, no symbol file in current scope. Excellent. So let's go add that. So under IO, I want to create file.fey and have a struct file. File descriptor is an I32 because we're on Linux and I don't have conditional compilation. Oh, to do. Condit per platform conditional compilation. Excellent. So we're on Linux. We're on a Unix system, and so file descriptors are an I32, and we need to say. I really want a formatter. I'm gonna move that. How much of this do we need? Rand read, yeah. IO file. And so now it's going to complain that, oh no, I don't have that method. No method from FD on file. Blah, blah, blah. What I actually want to do, real quick. No method. Which one of these is static? That one's the static. I want to say no static method. No static method. Excellent. Much nicer. I like my compiler errors. That's a very important part of why I'm building Fey, is to have a very nice tool chain. That's like the other half of the equation. I'm only talking about the language right now because that's interesting, but having a really solid tool chain with good errors, very fast, very accurate, very stable, is an immense a part of the experience writing a language, from the compiler to the formatter to the language server to, I don't know, debug infrastructure, that sort of stuff. I haven't really thought too hard about that, but having really, really high quality compiler errors is important. So, oh, and yeah, I didn't even mention, this is how you call static methods, is you just have the type and then dot. Originally in the design, everything was going to be periods like this. And I ended up not going that way because that is more difficult to parse because it's ambiguous, kind what it is until you get to the validator step. So I did define between, oh, this is a dot get on a chain of structs, a field read on a chain of structs, or this is a chain of lookup path traversal. Like, it's definitely doable. I could have done that. I decided not to, and I've decided that I quite like this is for namespaces, and all methods, whether they're static or not, use dot. And I like that. It works, actually. I quite like it. I like how that turned out. It was kind of an accident, but I like it. Because it's, like, visually consistent, and it's consistent, like, logically, internally and externally. And so I like that. Not entirely because, oh, I'm operating on an instance when you have... That's fine. Usually dot what you would think would be operating on an instance, but in this case, I think it's fine, and that's, like, the one thing that's not, like, consistent about it. But everything else is. So I like it. So we need a method static file where we have from fd file descriptor is an i32, and we return a file with file descriptor. Eventually this will not be necessary. It'll be like that. But that day is not today. The compiler does not understand that yet, but that is in the design of the language. But for now, that's what we got. So no method read until new line on type file. Now notice I didn't change any of this code, but we're getting a different error now because when it wasn't able to get a static method on the type file, it evaluated this expression to a, I could be anything, please don't error on me type. And so when we then came down here and we tried to call a non-existent method on it, the compiler's like, I don't know if this is non-existent. I don't know what this type is. All I know is that I shouldn't error on this. And it doesn't, because it doesn't know what the heck you meant there. So trying to complain about that would be meaningless. There are lots of places like that in the compiler so that it can continue to emit other errors without a single error becoming truly viral. There are a few places where it does, but it's quite good at it, and the validator is quite better at it than the parser because the validator is actually working in structured semantic land, whereas the parser is operating in wiggly wobbly, I'm a series of bytes land. So the parser handling errors is a lot more heuristic based, and it's not very good at it, but it'll get better. It'll get better. I haven't really thought about that hard. So the like 2 heuristics it has is very simple, but they tend to work. Not always that well, but they're better than nothing. Anyway, so we actually do have a file object, right? So it's like, I don't understand read. So let's first write read, which is going to like read till end, actually. Yeah. Method mute file. I'm going to say you need mutable access to a file. That's kind of meaningless. But Faye doesn't have like, oh no, you shared mutability concerns because it's an unsafe language. So that doesn't really matter. And I feel like this is more semantically accurate that reads and writes. You're mutating the file, even though nothing about the file is being modified. It's about the standard, yeah, you know what I mean. You're just talking syscalls, so and passing in an integer. So like it doesn't matter, but I still think it's nice. So anyway, method mute file, that's the wrong syntax, and we're gonna say read until end. Cool. And we're gonna have a buffer, this is why we wrote that list type. Mutable list of U8. Excellent. Do we want to write read until end right now, or do we want to put that off for not in the demo? We'll just write read until new line right now. I think so. So the first thing we do is a buffer dot clear. Now, interesting that list isn't in scope, but it's not going to complain about it. But because list isn't in scope, this is upset. Actually, what I'm going to do is I'm going to come over here. I'm going to say Faye collections list, because I can, and I want to just show that the method still exists. Yeah, the compiler is completely happy with that. Can I? Thank you. And it's error right now because I'm not actually reading anything. But I actually do want to import list. Import Fay collections list. I don't love this, but I'm on the fence about having re-exports because I like, if I go into some Rust code in here, I like very explicit imports. I like very specific. Where am I? Like, none of these are nested or anything. So, like, I like my very structured imports. So I'm fine with this. Because eventually I'm going to build a language server. And so I type list down here, and one of the options automatically imports list. And it does it correctly. So I don't really care. I find that too much re-exporting can cause... It can be nice and sometimes, and other times just be like, why? Why? In the same way that overly generic code is. So this is the sort of thing that I might add re-exports. I'm not entirely against them. I just haven't deemed it necessary to work on yet, and it might never be deemed necessary. If I write a bunch of code in this language and I decide I don't need to add it, then I won't add it. Very cool iterative design. Anyway, so we clear the buffer and we need to read. So we need import Fay libc read. And read is a syscall. Xread. File descriptor. Why am I doing that? I have the signature right here. Right there. FD buffer count. Okay. So now what I could say is what I could, I'm in here thinking, I'm deciding between whether or not I want to have an explicit buffer and then read into the buffer and then copy into the list, or if I want to read directly into the list. I think I want to read directly into the list, which does mean I need to be able to reserve. Yeah. So what I need is, technically, I could just reach into the fields of the list and modify them, but I'm going to write this code under the assumption that I can't, for the sake of just, I'm going to have private fields soon, so write the language as though it's finished, so to speak. So I have clear, I have truncate, I can have method mute list, and we want a reserve and a set length. Reserve to length. And this is going to be vaguely kind of like this. Where we need to realloc, and that will give us, my brain just reset. We're reserving to the length, and so we need to realloc, and we also need to be able to free if we have gotten a new pointer. So I'm going to say new size here. I really want, my fingers just went to the format key on my keyboard. Oh, I do that and it's like, I don't know how to do that. Size of t times self.capacity. Actually, no. I want to say self.capacity. Ooh. if the length is larger, reserve additional actually, because we're gonna need to keep reading on to the end. Additional, yeah. And actually, what I could do is I could factor this out so that push uses reserve additional to capacity. Yes. Okay. I am actually going to do that. I'm going to recopy this just so that I have exactly. What am I actually going to do this to? New capacity is there. Yeah. So I can just say self.reserve additional I could say additional capacity is self.capacity. So we double it. If additional capacity is 0, additional capacity is 4, reserve additional capacity. And so I don't need to do any of that. Don't need to think about that. Eventually, Faye will have block expressions. So right now the compiler can handle block expressions, but you can't actually return anything out of them because I haven't implemented the keyword to do that yet. But like the parser and the validator all handle it. The compiler reasons about block expressions as being void returning, and in Fay, void is a valid type. You can create slices of voids. You can compare voids. You can pass voids to things. You can assign voids to a binding. You can pass void to a generic parameter, like as an argument to a generic function. Like you can just do that. Okay, so we have reserve additional, and see, I like I said, I desperately want a formatter. So new size equals self dot capacity. Well, actually, let new capacity equal additional capacity. Self dot capacity plus additional capacity. Cool. And so this should all just work. We have the new size, and then we can realloc, and then yeah. Okay, how does the compiler think about that? No symbol additional capacity in the current scope. I misspelled it. Additional. Cool. Okay, so now we have reserve additional, and I can come down here and I can say buffer dot. I can just say while true. Buffer dot reserve additional. And we'll say our, let's say const chunk size, we'll call it, is 20 bytes. Notice that I haven't given this constant a type. It's actually a 20. It's just a 20, and this 20 can become any type that any numeric type that it can fit into. And if it cannot fit in that numeric type, the compiler will give you a good warning. And that includes if you're like doing some sort of like math with other constant numbers on each other, and they result in some value that like would overflow the type you're trying to fit into. It'll tell you what the value actually is. I could demo that actually. I could say let A, which is a U8, equal chunk size minus 40, and it's going to yell at us, be like, constant integer -20 is negative, and so cannot be represented as U8. Look at that. Isn't that cool? Because who doesn't want a nice language that does nice things? Anyway, I nicked that from Odin, which nicked that, I believe, from Pascal? I have not given Pascal enough of a look to know whether or not that's true or not, but I think that's where that came from. Oh, actually, Go might have that. I need to spend more time with Go. Anyway, regardless, we would reserve the chunk size. And important to note is that I have called this const with Pascal case instead of Screaming Snake case, which would be chunk size. I don't like Screaming Snake case. I like Snake case for local symbols and methods and stuff like that, and functions. And I like Pascal case for types. But I don't like Screaming Snake case for constants. So I'm experimenting with just using Pascal case for constants. We'll see what I think. Reserve additional chunk size. Excellent. And so now we can read into that additional size. So we can just reach in and get the pointer. And so what we need to do is we need to get the pointer to the start of the newly reserved stuff. So we can say let original length equals what I'm realizing is that I don't think reserve additional is the right API, because if you repeatedly pass buffer into here, it's going to keep growing it. So I do actually want reserve, and the call site will have to do math if that's what they want. So we'll say new capacity, and we can just delete that. Cool. And over here, actually, I just want those. New capacity equals stuff to capacity times 2. Cool. And then this is new capacity, and this is just reserve. I like my words. I like my nice, well descriptive names. So we'll do that, and we'll reserve capacity, and we'll say original length equals buffer.length, and we'll say buffer.length time plus chunk size. So important to note, this is an I size, and I'm adding the 20 to it, and it just is the right type for that. And if I check, yeah, compiler's happy with that. And you see we are not exiting because we are now currently spinning my CPU in that one loop. Maybe? Yeah. One of my cores is fully maxed out right now. That's funny. Cool. So now we know we have the capacity, and we can get let pointer equals buffer dot items pointer dot size plus original length. This is where an offset API would be nice. What if we just stick into the prelude a offset pointer of t. Pointer is a pointer to t, or I need to have a pointer mute as well. And that returns a pointer to t. Oh no, that's not the right syntax. And we can just do the logic. So offset pointer by bytes is an I size. So this we're gonna offset by bytes. So it's not gonna be aware of. I could make this API aware of the size of t and have it do by that, but I don't want to. So I'm gonna say pointer usize plus by bytes usize, and then fine, I'll wrap it in parentheses. Is it going to do it? It does do that. Excellent. Don't love that. But, I mean, eventually this is going to become an intrinsic, and the compiler is just going to emit a call to this. Or actually, I'm going to have some sort of way to define methods on built-in types. I haven't decided how I want to handle that yet. But because right now you can't define a method on like a pointer or a slice or something like that, which would be nice, but the language just can't handle that. So we do that. And list actually should want that right here. So we can say, that's in the prelude, so I can say offset pointer. Do we need mute? We do need mute. Mute. And we're offsetting the self.items pointer. Pointer. And we actually need to tell it the type, which is t. We're offsetting that by this. So I can call that now offset, and I don't have to cast. I don't have to do casts now at the call site because those are both I size and this expects an I size. Offset. Look at that. Look at that. We get the offset. We offset by. We dereference that. All is well and good. I like that. So I need to do the same thing here. So pointer is offset pointer. Is that mute? It was mute. This also needs to be mute. U8. And I don't need to multiply this by anything because it's a U8. So I can just say buffer.items pointer. And then the original length. Cool. So that's our pointer. And then I can let bytes red equal read. Read once our file descriptor, the pointer to the buffer, and the count, which here is chunk size. Look at that. Also, important to note, right here, chunk size is being coerced to a, not coerced, that's the wrong term, because it's a compile time known value, so the compiler can shove it into different types if the compiler knows that that is safe to do. Right here, it's collapsing is actually the internal term for it, because it's like numeric types are in a state of superposition until they collapse to a concrete type. Ooh, funny. But here we're using it as a usize. Look at that, isn't that cool? We'll say if bytes. We'll say actually we need a resize buffer, so that set length is buffer.length plus bytes red. Again, we don't need to multiply anything because we're working with bytes. And now I can say if the last item in the buffer is a new line, we can just break. If buffer get, actually I want a last. Right here, we'll put it here. Method list, I want an immutable and immutable. Last. We'll say last t. And then we also have last ref. and then last mute, which is that. Okay. So if self dot is empty, we can have, we need print string. Stood out print string. We say print string cannot take last of empty list. And then we utterly destroy the world and we say exit. Exit with a -1. Exit takes an I32, right? I32. Yes, excellent. And then otherwise we can say self.item. Actually, we can just say return get. Self.get. Eventually self is going to go away and become that, which is pretty nice. Stole that from Yak. Haven't done it yet. So we're using self. Self is always going to be in scope because sometimes you need to pass self. But I like that. That implicitly dereferences self in a method. Specifically in methods. Doesn't exist yet. Just haven't implemented it yet. But soon. Self.length -1. Cool. So if length is 1, it'll give us 0. Cool. And so here I can go boop. Cannot take last ref, get ref, and then cannot take last mute of empty list, get mute. Excellent. And I want to make sure that the compiler is actually happy with that. No method set length. Did I not write the set length? Reserve capacity. I did not write the set length. Method mute list. Set length. New length. There we go. Cool. Nautical path for function offset to pointer return. Oh my god, did I do the thing again? I did the thing again where I didn't return because I'm so used to Rust. Why did you do that? Yeah, I somehow accidentally hit a key chord when I meant to do that. Okay, so the compiler's happy with that. There we go. Compiler is happy with that. Excellent. So if buffer last equals, and we're gonna have a new line. And interesting quirk about Faye, this is not a character literal. This is a code point literal. So this actually has a type of a U32. And so we can't just compare it against a U8 because that's the wrong type. Oh no. No. Okay. So apparently I haven't implemented escapes in code point literals. That's fine. I can fix that. That can be the thing I do after this. They're in strings, so we can do. I was gonna say we have to come in here and pass this to a U8, but I don't actually have strings. Like, I'm sorry, I don't have escapes in code point literals yet. So I'm gonna say you're a string. I'm gonna get the 0th element of the string. To do. Add escape sequences to code point literals. Cool. Okay. So now that we finally hit a compiler error. We finally hit a compiler crash. Woo! Look at that. Type store. Left equals right. Oh, function generic. Really? Really? Okay. So we expected to hit a few bugs. I'm surprised we got this far without any bugs, which is pretty cool. I knew that any bugs I hit was going to be in the methods, and it is probably in the methods. Why? If I don't call buffer last, if I get rid of that. Yeah, so the compiler's happy then. I'm going to do... I really want keyboard shortcut for that, because right now the editor does not understand what this is. This is just plain text, so it doesn't... I can't just, like, automatic, like, toggle comments. But let's say buffer.last. Is that going to panic? That does panic. Okay, so I goofed something. Oh, no, I know exactly why it broke. I know exactly why it broke. No, because it didn't break there. It hasn't broken there. What is different about last? Set length and last. Oh, that's what. So what I'm going to do is I'm going to, we know it's not empty. So I'm just going to do, oh, get's not going to, we're not even pushing, right? So get's not going to work either. If I say get 0, that's also going to panic. No. Okay, I'll dig into that more later, but we'll say, we'll just use get 0. To do fix buffer dot last ice causing an ice. Ice is internal compiler error. Okay, so is the compiler happy with that? It is excellent, and also, if you noticed, it actually we seg faulted. We seg faulted, of course, naturally. Probably an A2L, but I wouldn't put it past this being a cogen issue. I don't know. We'll figure out. No. Okay, is it buffer push? It's probably buffer push. No. So it's probably actually somewhere inside read until new line. Break. Turn. Interesting. What's annoying here is that I can't really easily debug this in the middle of a demo, but just to confirm, it's definitely in there. Yeah. And it's probably here. Yeah. It's probably a cogen bug. Let's dig into that, because why not? I might be able to spot it. So here's the intermediate representation that is generated. So we know it's in read until new line. Good Lord, look at all those allokas. Condition. What do we call buffer get? And then in here, I want to search for get. Right here. Here's what I call get. If I just call get, will that... Of course, that's fine. It just won't die. Oh, it might actually be in... like, buffer get might actually be wrong. That would be so funny. Yeah, what if buffer get's just wrong? Like, it probably is. So we items pointer usize plus size of times that, and then now what's interesting is first generic list. This is basically doing the exact same thing. Offset is cool. Size of times index. What if I say get ref? It's probably the dereference. Okay. I didn't screw up the precedence, did I? Surely not. No. Didn't screw up the precedence. Okay. So what's interesting is that it works here, but not here. Clearly this pointer here is wrong. Items pointer. Now we know that the pointer is actually valid because we're like reading into it. And we're not getting a seg fault from within that. So let's actually debug this. Print iSize, print usize. Oh, I don't actually have a print iSize, do I? Stood out. We're getting so into the weeds here, but that is A-okay. iSize, and then how do I print I64 LD? Cool. That makes sense. So I'm gonna come in here. I want to say print iSize. Print usize. No, I'll say print iSize. Size of T. There's a reason that on the to-do, string formatting is the very next thing. Expected. Oh, duh. Oh, we don't even print those? Oh, because we're probably not flushing. Because it's using printf, so it will just do whatever. And that's in Fay libc. Oh, yeah, that's also in libc. 1 and 0. Yes, that should be a round trip. If I just say that, we still segfault. So a round trip of items pointer to usize and then back to pointer panics. If I just say items pointer, but we still segfault. So something is wrong with items pointer then. Oh. Aha. Found it. Found it. Okay. Actually, I want to undo all of that so I can have this back to the way it was before. Cool. And then boop, boop, boop. So I was never assigning from being 0. Reed probably, what's interesting is that Reed didn't die on that. But that is something for another day. Okay, so we're not exiting. All right, because this. Actually use it. If it's new line. Interesting. Escape sequences to code point. So we're in this loop. If I come up here and say print string, say that's still in scope, right? That's not in scope. Import std. Oh, we're in a different file. That's why it's not in scope. Std stood out print string. I need an actual print like yesterday, and not std fay. We're not actually looping. Let's do that flush thing again because I dislike. I should go into all of these prints and have it flush. Yeah, let's do that. Let's do that. F flush and stood out file. Stood out file. Yeah, it is stood out file. Cool. So we'll just come in here. We'll go to all of these. Doot 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 boop boop. There we go. Extremely inefficient, but let's not have to bother with that because printing for IO should not be buffered. Okay, so we are looping. See, it's always buffering. It's always buffering. Oh, we're getting duh. Okay, buffer dot length -1. We did it. Did it. Let's double check that we're not actually buffer len LD capacity is also LD. I can never type that because I never have to. String literals in fay are slices, but printf needs a pointer. Also, string literals in fay are currently defined to be null terminated just for ease of interop. The length of the slice does not include the null terminator. It just is there so that C libraries just won't read past it. But if you like start sub-slicing, you won't have it anymore in the right place. Technically, sub-slicing doesn't exist yet in the language, but that's one of the things I'm adding next. Cool. And this is buffer length buffer dot capacity, just to double check that they're not growing too much. For because we grew that one time. Capacity is 0. Never set capacity. Dot new capacity equals, no, dot capacity equals new capacity. Capacity is 20. Right, because we reserved the 20 bytes for read. 50 is too high. We'll say 25, too low. Same lane and capacity. If we type a whole bunch of gibberish. Look at that. Of course, A2L is still like, I don't know what this is, and just gives us a 0. But look at that buffer length and that capacity. Excellent. So I can come over and go boop. And so now we have officially made this API significantly nicer. So we don't need read anymore. We don't need flush anymore because we fixed that. Stood in description. We still need that because we're creating that. Stood out file is no longer necessary as an import. Print string, print I2. I'm going to leave those because I test things in this file. So, all right. So let's look at the diff for that program. We got rid of that. Now we have a file. I can't exactly resize this, so I'm going to do that and then zoom in. We have the buffer, which is a list. Printing is now flushed by default. We get this. We take the standard in. We read until new line. If the buffer is empty, we break. Yeah, if I do that. Oh, interesting. Buffer len is 2. So one of them is going to be the new line. What's the other one? Right. So that doesn't actually help us. Until new line. That doesn't actually help us. What is the 2 items? Let's do a bit of printfing because I am lazy and I don't want to have to write out multiple print underscores. We'll say 0 is, what do I use for? I mean, I could just use D because it'll work correctly, but I want to do the correct thing. Print U8 is, oh good lord. Printf was a mistake. Is that, and then 1 is that, and we can say buffer.get 0, buffer.get 1, and I'm curious what those are. Oh, read inserts a, I didn't know that. The read inserts a, I mean, it makes sense that it does, so we can get rid of that. Cool. We could actually come in here and say like a starts with or something, but I don't have any sort of string manipulation stuff, so look at how much nicer that program is. Too low, 75, too high, 59, well, too low, yeah, 65, too low, 70, too low, 74, 73, 72, 71. Okay, so check that out. Look at how nice that is. Look at that. And look at that. Isn't that cool? All right. We wrote a whole bunch of code. Whole bunch of code. Look at all that code. Look at that. It's real code in a real language, doing real things. with generics and objects and methods. Wow. So let's talk about remaining features for a minimum viable language, because the language, there's a difference between the language and the toolchain. Minimum viable toolchain also needs a formatter and a pretty minimal language server in order to be a minimal toolchain. This is not that. This is what features need to be in the language. This does not include things that are like poorly defined right now. Kind of, but we need private fields, string formatting, slice slicing, and arrange types. That is where you can take a slice and take a subslice of it. Defer, because again, like I said, Faye is taking the approach that structures are just data, and if you want to operate on them, you do it. I have some interesting ideas about how defer works with like cleanup with like moving objects around with move semantics, and lets you achieve move semantics without requiring language support in how destruction works, which is pretty cool, by letting you still have the nice parts of RAI whenever you're not moving, and then still stick the cleanup in the code at the end of the code paths where you're not moving if in some of them you are moving it. I have a blog post I'm writing about that because I have some ideas and some thoughts about that. Block expressions, unions and sum types. I like my sum types and pattern matching. That's very important. Error system. It's kind of a mix between Rust and checked exceptions. That sounds really strange. It's kind of like a mix between Rust and Zig, honestly, but a little bit different. You'll see. Traits. Operator overloading is going to be via traits, and then once traits, some sort of for-in iteration. Named parameters and field name match omitting. If we go into here, that's this, where it matches, so just stick it there and it works. Name parameters is where you can have a parameter to a function require a name, and it also has the same name matching thing where you don't have to stick the name there if the expression is a variable that matches the name. Statically sized array type, that is easy from the compilers, from the cogen's perspective, but non-trivial from the type system's perspective, because the type system has to know all of the different individual types of arrays with different lengths of that specific type that it's an array of. So the type system needs to become a little bit more performant for that. Functions inferring generic parameters from arguments. So if you have like a function that's like generic over t, and then you pass in a list of t, you don't have to specify t on the function. It can infer it from the argument. Anonymous structs. Very important to me. Anonymous structs. I don't like tuples. I want anonymous structs instead. Per platform conditional compilation. Constant structs. I'm not sure if I want constant evaluation, like const eval, or like const functions. I thought I did, but it really heavily reduces the ability to, not reduces, it really complicates the multi-threading of a compiler. I think for the minimum viable language, I'm not going to have it, but the door is still open. But what I do need is to be able to create struct instances at compile time as like consts. Multi-line strings, I'm thinking just Zig style syntax for that, because I think that's a really clever idea. And then glob imports. The import system right now is implemented a little bit weirdly. And so that'll be like cleaned up a little bit there. That's the minimum viable features for the language to be useful in the way I want it to be. And at some point along here, I need to write a formatter because I'm going insane. But we wrote some real code, doing some real things with these new methods that are brand new to the language, and we used some unfortunate stuff. I'm gonna fix that compiler crash. That's easy. Every time a crash for a program I've written happens in a demo, it's really rewarding to go fix it and be like, I fixed it. All right. I don't even know how long this recording is. Thanks for watching if you have. I don't expect anyone to really have, but I am so excited that I finally built a language that's actually going somewhere useful. Isn't that cool? All right. Thanks for watching.